Hi guys, this video is for Unit 5, Section 2 over quadratic inequalities. So here we have our function right there, x squared minus x minus 6, and they gave us the graph. Okay, so when I first look at this standard form right there, it doesn't really mean anything to me. I don't have the vertex, I don't have the x-intercepts, so I just want to do something with it. So I'm going to go ahead and change from standard form to factored form. So when I look at this, I can just factor this in my head, and I know two numbers that multiply to -6 and same two numbers that add up to -1 will be x minus 3 and then x plus 2. Okay, I feel a lot better now. I know that these factors will give me the x-intercept. From the root form, we had f of x. From a couple lessons ago, we have x minus r, and then x minus s, and those represent the roots of your function, or the x-intercepts. So remember, the minus belongs to the formula, so your x-intercepts are 3 and -2. And that's what you see right there on the graph. Okay, now that we understand what the quadratic equation is and what the quadratic function is, we're going to start talking about inequality. What is it? What does that mean? But it's not set equal to 0. Why would it be? Anyways, but we're better than this. So -6 on both sides, we have x squared minus x minus 6 is greater than or equal 0. So when I see this inequality, I think shade above, and I also think solid line. Because I've done this before with linear inequalities, and that's what I remember. So greater than or equal to, it's shade above, and it's solid line. Okay. But now we're thinking, what is that 0 doing there? So we're shading above 0. Okay, that's all that means. It means above 0. Okay. So at what values of x do you think makes this statement true? Well, values greater than or equal to 3, because I'm looking at that graph right there. So I have 3 right here. I have 4, 5, 6, 7, 8, 9, 10. So all of those are leading my graph to greater than 0. That's why I chose that. Or I also have these values right here on this side. So anything less than -2, -3, -4, -5, -6, and so on. Or values less than or equal to -2. Okay, so if I were to create a number line of what we just talked about, so here's my number line, here's 0, here's -2, here's 3. It would look like a solid dot because it includes 3, and all the numbers or all the values greater than or equal 3. That's what that means. And here, solid dot right there, going that way, all the values less than or equal to -2, right there. And if you compare this number line to this graph, those are the numbers, those are the values that are greater than or above 0. Those right there. What if we have the same inequality, but with the less than or equal sign? We already set this up equal to 0 right there. But here, this inequality, I think, shade below 0. and it's still a solid line. So what values do you think makes this statement true? So we're going to look at these values right here, right below 0, right below 0 right there. So all the values between -2 and +3. So any of these values right there between -2 and 3 are below 0. Okay, here's the number line. You can't see. So here's 0, here's -2, here is 3. That's my number line. So all the values between -2 and +3 are there below or less than or equal to 0. Okay, so here's the graph of x squared minus x minus 6 is greater than or equal to 0. So here I see that this number right here is -2. This number right here is +3 from the previous page. And this part right here is above 0. And this part right here is above 0. Okay. So create the number line from the previous page. We already did, so it's right here. Solid going that way. And solid right there going that way. Toward -infinity, toward +infinity. And that's to represent those values right there above 0. Write the solution in interval notation. So from -infinity to -2 inclusive, because it's a solid dot, because it is a greater than or equal 0. So that's inclusive. Union symbol, inclusive 3 toward +infinity. Now as a solution set, we have x is the set of all numbers in which x is less than or equal -2, or x is greater than or equal 3. So how many pieces are there to the solution? Well, there are 2 pieces. Very similar to this. Now we have the less than or equal sign. So this is the graph that represents x squared minus x minus 6 is less than or equal 0. So in that less than or equal 0, the below 0, we're looking at these values right here. They're below 0 right there. And here I have -2 and 3 because from the previous page. Okay, so I have -2, +3, and all the values between -2 and +3. Write the solution in interval notation. So I have -2, +3, and they're both inclusive. Write the solution set. So x is all the numbers, is the set of all numbers between -2, less than or equal x, less than or equal 3. Okay, how many pieces do we have? We have only 1 piece. 1 piece is all together, 2 pieces, it's like split up. Okay, now, every time I have x equals, or x is greater than or equal c, c is for the constant. I want to put something here before you get crazy. So this only works when the leading coefficient is greater than 0. That means when the leading coefficient is positive, then what we're going to talk about is true. Okay, and the main thing, so you already know that the line will be solid. So solid line is solid on both of them. So line is solid. Here you're going to shade above 0. Here you're going to shade below 0. Shade above because it's greater than, shade below because it's less than. All right. Now, again, because the leading coefficient is positive, this only works when the leading coefficient is positive. When it's negative, we're going to talk about this later. Solid line, shade above. What else do we have? We have closed dots. I'm talking about these closed dots right there. I forgot the D right there. Closed dots. We already talked about solid lines. Oh yeah, and if we're talking about interval notation, they are inclusive. And that means you're going to represent that using brackets on both. The only difference between this one and this one is where you shade. Oh, the number of pieces too, right there. So 2 pieces, and then you have 1 piece right there.